Hi everybody, hopefully you can all hear me. Just going to do a quick sound check with the volume and stuff. Cool. Okay. Welcome. Now, we don't have a lot of people here today. We only have 5 in fact, and I don't have a second screen with me, so I'll have to kind of bounce back and forth between a few things here if that's all right today. But this is a very straightforward follow-up lecture from the one we had on Monday, where we kind of just ask people, what is it that you want to learn a little bit more about when it comes to front end? And I'm just pulling up the questions now. The questions we had were that Ched wanted to know more ways to add animations using CSS and JavaScript. Siyoung Cha says history of JavaScript and how it became the main language for web development. And that's actually the only 2 questions we got from people. So if people do have more questions that they'd like to ask, that you can ask in the chat so I can monitor it, that would be great. Otherwise, I'll just try and fill the time with some vaguely interesting things for everyone today. And again, there is no rhyme and reason to this besides I teach a lot of front end at CSE and would love to get people excited and inspired about it. So one of the first questions I got there was about animations, and animations are really interesting because I want to just give you a taste of something. So remember, HTML, CSS, and JavaScript, those 3 languages have expanded their capabilities over the last 20 years, 30 years now, but largely they've been there since the start. And when you go way back to the beginning of the web, JavaScript was responsible for pretty much every single dynamic behavior, maybe with the pretty much every dynamic behavior. So what that meant was, like, if you clicked something or did something or a time hit and the page changed visually, it was pretty much guaranteed to be JavaScript. And I'll just give you a quick example of what I mean here. I'm going to go make a little div. I'm going to call that div box. And I'm not going to put anything inside of that div, but what I'm going to do is I'm going to give it some style. And this particular style is going to be, it's going to have a width of 50 pixels, a height of 50 pixels, and a background of blue. It's just going to come up on our page and look really simple like this. Now, if I wanted to, I could add some JavaScript to the bottom of this page. And I could say, you know what I want to do? I actually want to write a function. I'm going to go put a button here. Button ID equals like move. And I'm going to say document.getElementById move. Add event listener. We've already kind of seen this stuff. When someone clicks this button, I would like a function to be called, and what that function is going to, that button doesn't have any info in it. What I want it to do is I want it to basically add a margin, a left margin to that box, some padding on the side, if you will, that is 10 pixels. So I can go and look up my particular box, and I can say, if you want to update a CSS property of a particular HTML element, you can access it by, once you get the element, you say .style, and then you refer to the CSS element, which in this case is margin left, and you say you want it to be 10 pixels like this. So when I click that, the margin goes from 0, which is the default, to 10 pixels. Now what happens if I want this every time I click it for another 10 pixels to be added? Well, what we're going to have to do in this case then is get the current margin left and then add 10 more to it. So if I simply console log the current margin left and I open this up on the side here, we'll see what happens when I refresh the page. I click that. Oh, you can see that, it says 10 pixels like that. So by default, margin left will be 0. So I can first say say const current margin equals that. And what I saw before was that, hey, the first time it's run, it's actually blank, right? There's a lot of idiosyncrasies to JavaScript, like, it's not just 0 by default, it can be blank. So I say, if current margin is blank, then I want to set, say new margin is equal to 0. New margin now will be 10. And if it's not blank, well, what I need to do is I need to somehow extract that number 10 from the pixels. So I could say, well, new margin is, I'm going to go get the current margin, I'm going to replace the px with nothing, and once I replace the px with nothing, I will then have to convert it to an integer. And then I will add 10 to it, like that, and that'll be our new margin. And then I can simply say, well, you know, the new margin will just be new margin pixels, like that. So now every time I click it, what's happening is it's moving that across the page. Now if I wanted to, I could not do that based on a button click, right? I could wrap all of this in a function, and I could call it move box, like this. Easy. And then what I can do is I could say, well, I want to call move box. Now obviously this is going to run the exact same stuff here, like this, right? However, instead of doing it based on a button click, I could also do it based on a interval. Now, we did talk about set timeout in 1531, but set interval is the same thing as a set timeout, except it just keeps happening. So what I could say is, I actually want you to call the movebox function every 1 second and move it 10 pixels to the side. So when I load this page, I gotta put that below the function has to be defined before I use it, which makes a great deal of sense. Yep, so now it's moving every 1 second, which is pretty cool, and I could make it move much faster. There we go, like that. And it'll just kind of keep moving forever. Now what I've done here is I've used JavaScript to animate the page. And this is how animations kind of have existed since the beginning of time. However, with newer and new additions to CSS, CSS is now capable of doing more animations, just like the ones I showed you in the previous lecture. Why would you ever use CSS to animate stuff over JavaScript? It's a great question. The reason is because CSS is, I always like to compare it to like CPUs and GPUs, right? A GPU, like a CPU can do a lot of things that GPUs can do, but slower. And the reason they're slow is not because the hardware is worse, it's because a GPU has a bunch of capabilities in it that are like absolutely specific to a particular application, which is about rendering. Whereas the CPU kind of has a really baseline tool set that can kind of do everything. You know, it's a little bit like, you know, like you can hammer a nail into the hammer. So you can screw something in with a screwdriver, or you could use a power drill, right? They both get the job done, but a power drill is really specific for that use case. But there are things a power drill might not be able to do. It might not be able to fit into a tight corner. It might not be able to be carried around easily. It might not be the best, you know, truly universal tool compared to a screwdriver. I don't want to imply power drill is not a great universal tool, but the point is that they're different tools, but they can do the same job, and some of them simply can be more efficient in those particular cases. Now, that's an important detail, because when it comes to this like CSS and JavaScript situation, when CSS does animations, the people who implement web browsers really specifically bake in that capability to be as efficient as possible. Whereas when we do something like this in JavaScript, we're essentially using all these general capabilities to do things, and it can add a lot of load and resourcing. So basically CSS is usually your preferred place to do all dynamic activity, then JavaScript. It's just that the capability of CSS is really small. The other cool thing is that with things like LLMs nowadays, it's actually really easy to go and make a very straightforward little animation in CSS without having to figure it all out. So for instance, if I want to say, I want to animate the word Hayden, I want it to start by not existing and then appear suddenly and grow in size whilst having a crazy rainbow color. I'm building an HTML CSS page with no JavaScript right now. I don't know, I haven't prepared this before the lecture. So we'll see what it does. It kind of spits out a page. It's got lots of extra stuff in here. You can see that what it's done is it's done similar things to what we talked about previously, where it's created these keyframes with like a rainbow, where it shows that it's going to oscillate between all those colors: red, orange, yellow, green, blue, indigo, violet, red. It's going to grow in size from like completely invisible to visible to like really big. And it's simply created a piece of animated text called Hayden. It's actually this is a great output, really. Great example of where these LLMs can be really powerful. If I then come back to my page here, and I do that, you'll see Hayden does that. It like starts off as blank, and then it appears and grows like this. And you can see there's a lot going on here. For instance, it's saying the animation should, I need to call grow. I want it to happen over 3 seconds. I want it to only happen once, as in forwards means I want it to start from the beginning and get to the end. So grow from nothing to something once. And then I want to apply rainbow over a 3-second period that goes infinite. That means that it's just running all the time. So when it comes to CSS animations, I would actually really recommend the use of a lot of LLMs because there's examples online, but they can be really difficult to wade through. And it's interesting, the questions I get from people like, why are you encouraging this? Aren't students in your course going to cheat and stuff? Because there's a whole course I run on this topic. And the answer is, it's a tricky one because we all grab code off Google anyway. Like there's a website like CSS Tricks Animations. There's a website out there like this where you can go to and it gives you code. What's the difference between this and an LLM? Why don't we just give you the CSS standard booklet and you have to interpret everything from that, as an example? And the answer is because, that's just kind of not how we work, right? We take little bits of inspiration online and we tweak it. So when it comes to like a fair use of something like this, sure, if you use this as a baseline, but then I use this to go and learn more and to kind of play around with the colors and the speeds and make it my own, then that's really where some of these things can be quite powerful. So I'm just jumping to a couple of questions. So there was a question about that was a comment around, so it's specialized and optimized for that. Yeah, exactly. Because remember how things work is that there's international communities that what they do is they say, what would be really cool? Shadows on boxes. And I tell people this story. I don't know if it'll be possible to show you because I don't think I'll be able to Google it. But what used to happen a long time ago was if you wanted to make a shadow in a box like this one, you'd have to make a box and then the orange box inside of it and then some rectangles here and a rectangle there. Like you could make a shadow, but it was basically the collection of images. It was very, very hacky. And then people were like this one. I don't think you can you do this with CSS now? Wow, I didn't know you could do this with CSS. It's like, someone was like, well, people seem to love shadows. Why don't we just make the capability within CSS? Sorry, some ad is causing me grief here. So, can't get rid of it. So that we can do lots of cool stuff. And it's just more efficient. But anyway, the point was there's international bodies that basically come together and say, this is what we think CSS should do. And then they publish it, and then lots of web browsers go along and say, hey, I can do that in my browser too, right? So it's like classic language is defined, then the compiler comes along too. So if I look at, say, what is it, like CSS version browser compatibility? Let me see if this shows anything. Yeah, so you'll see here that like all these different CSS properties are supported in different versions of the browser. And in some cases you can see here there's ones where only Firefox actually supports it. Or where, it's only supported in the latest versions of things. Because if you think of web browsers like compilers and you think about, Chrome and Safari and Edge and Opera and Firefox as different compilers, there's one language standard and then they all go and implement it. And the reason that some websites look different between different browsers is because compilers are very big, complicated things, and each compiler will have its own idiosyncrasies where, they interpret something a little bit differently, or they just didn't fix a bug with something, or whatnot. So that's kind of where those variances lie. Someone asked this question as well, which was, what's the difference between different web dev frameworks and why is it constantly evolving? So, like any language, there are frameworks, right? Like in Java, you have the, I can't remember it. It's not Spring. Spring's like a build environment. Python had a really popular one called Django for a long time. Node.js has frameworks like Express, more a library. Usually a framework is like a library, something that you import to your tool to utilize its capabilities, right? A framework is like an entire setup structure, right? It has everything kind of laid out for you. It can often be the difference between, like a template when it comes, a framework when it comes to a programming language is like walking to IKEA and seeing a kitchen there, and you want to change the colors of tabs, but someone's kind of already laid out the gist of it because a smart person was like, this is kind of how a nice kitchen is. So there's smart people out there who say this is kind of how a nice programming experience should be. There are different kinds of frameworks out there. The most popular ones have been Vue, Angular, and what's this other one? Factors? No, yeah, right. Vue, Angular, and React. These three things have probably dominated the space more than most other frameworks. Angular actually came out first. It was written by Google a long time ago. When I say came out first, it was popularized first by Google. And it was basically saying JavaScript sucks. Actually, quick history. So JavaScript's been around for a really long time, right? But it's a little bit clunky, right? This stuff you see me write here is a bit ugly. What happened after that was there was a language called jQuery that came about in the mid-2000s, right? 2006 it says here. And jQuery was the next cool thing. And jQuery was basically a trivial abstraction of JavaScript, where if you wanted to write this particular line here, you would write this one in jQuery like this. I'm trying to remember the exact. It would be something like this, right? A little shorter. The cool thing about jQuery was it was really easy to learn if you understood JavaScript, because it wasn't a framework. It was literally like a syntactic wrapper to get rid of all the crappy parts of JavaScript by just making a mild abstraction layer, and all of these things just kind of correlated to very direct commands, you know. So that was kind of how that came about. But then later on in the kind of early tens, React, Angular, and Vue existed, and Angular picked up a lot of attention. And one of the earliest Angular demos was, I don't remember it, but it was something to do with like it was like state management example. They basically showed a really simple page where you would go and like update a field and it would live update something. And all of these frameworks, I won't get into it because it's too deep, but they're all about more efficient state management. And Angular got a lot of attention really early on. React kind of came in a few years later with a bit more attention by Facebook, and that picked up a lot of steam. And then Vue really hit it off, I think, maybe like a few years later in like 2019. But as far as I can tell, it's kind of become less prevalent, and React has just dominated. I don't really have a strong view on these things, no pun intended. Like, I think React to some extent ends up in one of those buckets like a Java or a C++, where there's a saying I used to love, which was like, there are good programming languages and there are the programming languages people use. Kind of the funny thing, because what always happens is that someone always comes along with like a much better version of something, but no one ever uses it, so it doesn't become popular, and if it's not popular, it's not useful. So a lot of people will say like, Vue, it's so much better than React, and it's different, but React is just common. It's just used everywhere at the moment, and therefore, when you're creating an organization, having people that understand React is really useful. So it kind of self-fulfills to some extent. It reminds me of, CSE, like a common thing with CSE is always like, go study at UNSW, and, people will be like, I hear students say this all the time, they'll be like, I can't say it's got the best education in CSE in Sydney, but they're like, it has the most students, and it's like, the fact that there's all the most students means that like you get all the best students, and then for sure, in my view, like, there's so many good students that come out of UNSW, and that attracts other good students to come in, and you get this funny effect where if our teaching or my teaching was good or bad, all the students, they kind of self-propel each other. So it's like, React is really popular, therefore it's going to keep getting popular because everyone's using the bloody thing. What was the question exactly? It was like, difference between them. It's hard to go into in this kind of level of detail, but it's I think it's probably best summarized by some of these things here, like learning curve. It's like they're just different. I'd say Vue got popular because it was a lot less difficult to learn, because you still wrote like your HTML, JavaScript, and CSS quite differently. So if you understood the stuff we've talked about today in the previous lecture, in some ways it was kind of quicker to pick up. But React's not easy to pick up. Like, I see this all the time, people trying to teach React to first years, and I'm like, that's such a crazy idea, because there's so much to it, and that's kind of why some people might prefer a framework like Vue, because it's a bit more straightforward, and people can make great applications out of Vue because it is just a little bit easier, for sure. I wouldn't too much read this table's differences, because there's some subtleties there, like React is also TypeScript, and I'm sure Vue's TypeScript as well, but yeah, it's probably difficult to get super deep in that question without a lot more time together. You can go do the front-end course. We can talk about it in more detail. This question from Seong about history of JavaScript and how it became the main language for web dev. I mean, it's just, I don't know if it's that rich. Like, when they kind of made browsers, they just made a language. Like, it's not like it had this big, I mean, it depends what you mean by web dev. If you mean front-end dev, it's been there since the start. If you mean back-end dev, then yeah, it's kind of what I mentioned on Monday. It's like, when it comes to back-end dev, it just got popular because it was used on the front end. So people could just use it in the same space. Like, JavaScript would not be so common for server implementations at the moment if it wasn't the language of front ends, basically. That's the short story. Yeah. I can go deeper if there's further questions on that. And I kind of answered Chet's question about ways to animate. Rennie also asked the question, comparison to different web front-end technologies. I kind of alluded to it a bit. I mean, again, you basically got like JavaScript, jQuery. jQuery is a nice little abstraction of JavaScript. Then you've got React, Angular, Vue. And you can kind of see the differences. Like, let me just look up some React code, right? And then I'll look up some Vue code. And then I'll look up some Angular code. And we'll just kind of compare the three of these, right? So like, when I look up some React code, look up some Vue code, and I'll look up some Angular code. I don't do a lot of Angular or Vue these days, so I could be looking at some old things. But what you'll notice, if you look at that and you look at this and you look at this, they all look like JavaScript, but they clearly still look different. Like, this is very clearly a React code. Vue is very markedly clear because it kind of, again, really separates out the JavaScript and the HTML. Like in this case, it's quite, there's the HTML, there's the JavaScript. There's not a lot of intermingling of them, generally speaking. And Angular, and I think, is a little bit closer to React. That's very not a good example. Yeah, I mean, they're just different styles. I don't know how to go much deeper without going a lot deeper, is the main issue. But they're all fine. Like, they all work perfectly fine to build systems. Because remember, like, unless you're building a system for thousands of people with 12 employees, it kind of doesn't matter. Like, it really doesn't, like, in terms of React, Angular, or Vue. Like, they're all fine. It's only once you get to the bigger applications that people then often are like, well, okay, what's the industrial example of this one? Okay, give me some questions. I need some more questions so we don't just kind of run into a dead end. Popular frameworks used essentially shapes the entirety of the industry as they follow along. Yes, that's true. Yes. React seems to just be picking up, but it's hard to tell. I don't like being assertive about this stuff either because like, everyone's in bubbles, like, we all live in bubbles. Like, to some extent, I run this course at CSE that's used React, so all the students have learned React and they all go into React-based jobs. And I kind of taught the course because a lot of the jobs people go into in Sydney are React-based jobs. Like, for all I know, there's like most of the frameworks used by most companies in Berlin is like Vue or Angular or something, or I'm not too sure. So I don't want to speak super dogmatically about it. But this other question, what do we use at Perla? So Perla we use Express, just like 1531, and on top of that we use React. In particular, we use a version of React called Next.js. Next.js is like React with... It's really funny because people talk about React like a framework. You can kind of think about React, you can think about it one of two ways. React is a framework for JavaScript. The other way you can think about it is React is one of the declarative languages, and Next.js is a framework for React. It kind of gets a bit heavy, but basically Next.js is like you code in React, so you're writing React code, but you have to do it in a really specific way based on the Next.js way. But the reason for that is because they have lots of things around optimizing pages and server-side rendering, stuff that's really important for Google and SEO. So like this is a very popular framework for websites that have need to be really high performance on the front end, which usually isn't that big a problem. Or in our case, websites that have big front-end exposure. Sorry, not front-end. Public exposure. Like, a website like Netflix wouldn't need this because with Netflix, you don't really do much on Netflix until you log in. Whereas a company out there like a bank might need this because they've got lots of info on the internet, savings accounts, mortgage accounts, home loans, like everything else. So we use Next.js and we do use TypeScript as well. TypeScript's a great thing. TypeScript is a really great thing. Like, we don't do a lot of it in 1531 because it's hard to go super deep in it, but it's so powerful. Like we nearly don't give static verification the credit it deserves. I would say that if you could only do like dynamic testing like Jest, or you could only do TypeScript, in my opinion, which is just my opinion, I would do TypeScript every single time because you just pick up on so many problems, and they're so easy to pick up on and document. Like types beg themselves to be answered. With tests, you have to figure out what to test, how to test them. With types, you just write them in. So we use TypeScript as well, definitely. Cool. What other questions you got? Trying to think about give me some questions. Like, I could talk about a million things. Is Perla hiring? No, we're not hiring at the moment, but maybe you can one day. We've got enough stuff. As a startup, we have the money in the bank to hire people, but it's just like when you hire people that you don't need, you run the risk of having to let them go. Which we don't like doing. We don't like, hiring people just to get rid of them again. It's not very fun for them. It's not really fun for everyone else. So we try and hire very intentionally, and we just don't need the people right now with the money that we have. So that's the really short answer. Okay, I'm thinking of choosing a major for computer science degree, and I'm not sure which to choose. Maybe security. I don't know a lot about majors. I remember asking about them years ago, and someone kind of said they're not really like a real official thing. They're just more like guidance as to what courses to pick. I don't know. That was like 7 years ago. So if the information on that's different now, go check it. Then don't listen to me. But I just do the courses you're interested in. There's two good reasons to do an elective. One is because you feel like without this knowledge, you are inhibiting yourself. You're really handicapping yourself. Like when I was at uni, I didn't do much on machine learning, which was fine because machine learning was not as big a topic back then. And even now, like the type of machine learning we do at uni is really theoretical. Like most jobs don't need you to be a machine learner. They just need you to be able to use AI, not like build AI. So networks is a good example. I think networks is a course that a bunch of students should do or like to do, because if you understand computer networks, like nearly all software we write these days is sent over networks. But again, that stuff changes because, cloud providers are really good at obstructing networks now. But yeah, doing a course because you're like, without this, I feel like I'm not complete, is a good reason. The other reason is just because you like it. Uni's meant to be a time where you kind of try and do random things, or you want to try. Like I did a course on knowledge representation, which was very mathsy, proofs of, this being true and that being false, and it was kind of interesting, but it definitely didn't inspire me, and it helped me understand, like, I'm not a very good theoretical person. I really loved practical courses at uni, where you have to go and do something. So yeah, just do courses you're interested in. I think some people can overthink it too much too. Like, if you don't do all the machine learning courses or all the AI courses, you're not going to be like a good AI engineer. I don't think any of that's really true. Most computer scientists could do most things, because most things that you learn at uni as a graduate you can pick up really, really quickly anyway. Even things like front end that we're talking about today, like they're all pretty easy to figure out. Yeah. If I like C, do you think you'd like C++? Yeah, probably. But it's hard to say. C++ is a funny language. It's a hard language. If you want to learn a language that's like exceptionally powerful, but exceptionally hard to use, then it's a good course. Like C++ is a language used whenever you have no, margin for error. Like websites don't need to be quick. Express servers don't need to be quick. You think about how long your Jest tests take to run. It takes like seconds. It's not that hard for a computer to do it, but who cares? Who cares if a test takes 10, 20 seconds to run? Whereas C++ is really like the difference between 20 milliseconds and 200 milliseconds is meaningful. But to have a language that is so performant and to write it well is a challenge. And some people enjoy that. It's a powerful language. Cool. Any other questions? Okay. Really scraping the barrel now. What makes me happy? Got asked this a while ago. I said to someone that the only two things I found that have always made me feel good, unconditionally, have been music and sport. So I wouldn't normally say that, but when I think about what makes me happy, I think about food and I think about TV. But yeah, I love music and I love sport. I'm not a sports person, by the way. I'm too busy, but I love it. What did I have for breakfast? Yogurt. I don't normally eat breakfast though. I skip breakfast, usually. Right, you guys are just trying to make me make up my own questions. Let's do 5 more minutes then if you don't have more questions. Just a reminder, so this would be a really easy topic to talk about in a couple hours if it was just like, here's the 10 things. But it's a lot like, the best example I can give is, web dev and all these languages like CSS are a lot like the Jest suite, right? In the Jest suite you had like, to be is exact, array contains, it was a whole array of different things you can use. And we didn't teach you much of it because once you know a few, you can figure out the rest. And it's the same thing, like with CSS, you can do colors many different ways. You can make colors like this with blue, I could do the RGB value for blue, which I believe is 255, 255.0. That's yellow. Oh, wrong way. Look at that. There's the color for blue. I can also do the hex code for blue, which should be 0000FF. Right? There's multiple different ways. I mean, they all represent a similar thing. Like 0000FF is just the hexadecimal version of the decimal version here, right? Because hex colors are just RGB represented with 2 hex codes. And then when you write blue, every browser just has some like, like what is the hex code for browser blue? Blue is that. So if I say baby blue, I wonder if I can write it like that. No, does it have to be a dash? Maybe I have to. I don't normally do colors like. You're generally discouraged from doing colors like that. I'm not sure how to do it that way. Interesting. I'm not sure how to write that in. But there's a bunch of hard-coded colors. They're probably all they're just shades of blue. Or maybe they're not even maybe they're not CSE ones. CSS named colors. Oh, just these, I see. Yeah, these are the colors you can use. It's a lot of colors. And they're gonna have particular hex values. But the point is, I don't, even I'm figuring this out now, right? Like, this is kind of what I'm trying to explain is that, the coolest thing about basic web dev is that the fundamental tools are really simple. The JavaScript part's kind of hard, but the great thing about 1531 is that you have learned it, and you've learned JavaScript, so you don't actually need to waste a lot of time trying to figure out exactly what's const, what's let, what's a function, what's this. Like, all of your time gets spent dealing with all this document.getElementById stuff. That's kind of where the real pain comes in a way. Yeah. I don't want to answer too many personal questions, mostly just because it's Yucha's course this term, and I work for her. I don't want to do a lecture on front end, and then she's like, "Why'd you just talk about breakfast for 10 minutes?" Are there any last questions about coding front end? Again, if you have any extra questions, you can just post them on the forum, to be clear, after the lecture, or you can come and do 6080. Or you know what? Great tip. I don't know if this is meant to be an endorsed thing, but just overload the course. Like, imagine 6080, right? Overload it with an intention to drop it. Then you just go do 4 weeks of the course and get a sense of it, That's always a fun tactic. It has mildly increased stress on your life, obviously, even though you're going to drop it, but that can be a great way to get comfortable with something as well. Yeah, just reach out or post on the forum, because I'd love to go further about stuff. It's just we could talk about it for hours. And I hope you enjoyed a few of the examples just around, the animations, how we can do these things. I mean, let's actually, here's one. Let's play around with ChatGPT again. Can we make web page have this effect with no JavaScript? I don't know, pretty negative. Interesting. I don't know. Let's see. See, this would be so much more efficient. This is a great example, because if you ask JavaScript to do this every 1 second, like, this is what I mean. CSS just has a very deep in its rendering engine know how to do that. Whereas with JavaScript, you'd basically be like really rapidly, like reading this, grabbing that, writing that, re-rendering that whole thing, like at a much higher level of abstraction. It's really no different to things like C++ and C2, right? Like, the reason Python and JavaScript are slow is because they're not working directly on stuff. They're working through abstractions. But you can see there's limitations too, because whilst this did do a pretty good job of making the example, I don't think off the top of my head there's anything in CSS that, actually maybe it can do it without being checked. Let me just see. move button. Maybe it just works without it. Yeah, I mean, look, I don't even need to press the button. It can just work for me. So you are seeing a trend where more and more stuff will happen in CSS, just because of its relative efficiency. But some stuff is still quite complicated. I used to tell students that like we, on our homepage of our website, we used to have, see this nice thing here, this background? It's just a gradient, right? Like I could go look up the gradient if I wanted to. That's not what I wanted to do. I wanted to just click on that and like find the background. Yeah, there's the background, right? It's just represented as like a linear gradient from all these colors. No one wrote that code. A designer made that in like a Photoshop, and then these tools can generate the code needed now. But the original version of that, it had this really cool effect where like it was like wobbling, like a lava lamp, right? And the way it made it look like a lava lamp was it was constantly altering the linear gradients as well as applying blurs to different points and stuff. And the thing was even though it was done in CSS, it was actually causing mobile phones to lag, because even though it was CSS, it was still just a lot of computation. And you'll see this a lot, like if anyone goes to like Apple's website's notorious for this. It's just like I'm on a MacBook, I'm on a high-ish end MacBook, so like it's not going to be too bad. But you go to some of these pages, like it's pretty smooth here, but you go open this up on a phone that doesn't cost $2,000, and you really feel it. And it's because they're doing so much with so many little web browsery things here, you know, like all these animations. That's probably a video playing, would be my guess. But you know, even notice the sidebars. Like even though CSS is quite efficient, it's still processing that has to happen, and that could be consuming. It's actually not too bad now. There was definitely some versions I remember where you'd like, maybe they moved away from it, where there'd be like, you know, there's those websites where it's like as you scroll down the like page unfolds kind of thing. Like I see ABC and stuff do it sometimes. It's like those things are so intense on a lot of browsers, which can suck. Any hacks with front-end development? Probably my favorite one is if you go to a website you like say apple.com, if you just right-click and you go to inspect, and you go find the HTML tag up here, and you just add content editable, like that. You just literally type that in. You can actually go and like, and don't click on something that's a link, but like, is everything here a link or something? Oh wow, everything's a link. Maybe that's a bad example. unsw.edu.au. This, you can go and like change it and be like, I literally can change the text on the web page. That did too much. Get rid of that. Be like, we really like having fun with our students, especially in the course COMP1531, and especially in iteration 3, to hack for life. You know, that's a cool little thing. I mean, I wouldn't really call it, it's not like a hack, it's just like, it's a really fun way to play around with websites if you like to. But yeah, you can't click on links with it because it'll actually just try and link you somewhere. But yeah, that can be a fun little one. All right, I've kind of exhausted the boundaries of questions, so let's just call it there. Again, if you're interested in more, come reach out. Like, we only really scheduled this for 1 hour originally, but we decided to do 2. I didn't think there'd be super many questions, but I'm glad we got to talk about a few other things. So if you like this stuff, come join me in COMP6080, and I'll see you in another term. Yeah, that's really it. Thank you, everyone. Thank you for the term. This is actually the last time you'll hear from me this term. Obviously, you'll hear more from Yuchao when it comes to notices and course updates and stuff, but I'll see you around CSE otherwise, and have a great